So this is my office, and I have two computers. There's the Smap spacecraft and instrument on top, and I use two computers to do all my engineering work. Here's the Smap web page, which you can go to. Just Smap at jpl.nasa.gov, and that'll tell you more about the mission. And what I do here, one of the main things I do is a thermal model. And what I do is I basically draw the instrument in our tools, in our computer model, and I use this to run different simulations of what it would be like in orbit. So whether it's going to be hot or cold or different scenarios where something might stop working and we need to make sure we can protect it. And so I have in here, the feed horn and all of its boxes. I also have the different electronics boxes, and all these, even though they show a different color now, all of these are just to make sure I can see them visually in this program. But with the real hardware, they're all a different color. But this is what I actually use to decide, what size of heaters or what temperature, how hot things are getting, how cold. And then I use that to order the different types of parts, whether it's a temperature sensor or a heater, and build that and assemble it on the actual hardware. So this is the JPL Spacecraft Assembly Facility, SAF, and this is where we actually build up our spacecraft. These are one of the rooms. And so this is Smap. This is the Soil Moisture Active Passive mission, and this is something I've been working on for the last 3 years. This is actually the instrument that spins on top of a spacecraft, and the spacecraft is right there. That's what's it's gonna sit on top. So all of this is gonna sit on top, and what I do on it is called thermal engineering. So I help make sure these boxes, like this black box right here, and these gold boxes over here, and this box right here, all of these things don't get too hot or too cold when they're up in space. And this very cool thing right here, this is actually what we call a feed horn. And the electronics, these boxes, send a signal from inside the spacecraft over there. There's a radar, and it sends a signal through the instrument and out through this feed horn. And then from the feed horn, it goes down to Earth and bounces off of the water in the soil and comes back. It gets captured back by the instrument, and that's how we can determine how much of soil, if it's dry or if it's really wet, and just learn things about our Earth environment. And so what I particularly do is thermal engineering. So you see these bundles of wires right here. These are all test hardware. They're test thermocouples. And what they do, and I can show you a few of them right here, they are actually just mounted on say like right here or other little spots. And this is actually a temperature sensor that we read in flight. And we'll put this in a whole test environment and see how hot and how cold things really get, and make sure that what we designed really works. Some of the design that we do is, picking what we call like the optical properties. So, like when you're wearing a black t-shirt out in the sun, you're going to get hot, whether you're wearing a white t-shirt. And so, for instance, this box here is painted black. It's painted black to make sure it gets as warm as it can. And then other things are attached. You see these boxes are all put on top of these plates right here, like a plate here, or this plate right here. You know, those are all plates that see space. So this whole thing spins around and sees space. And so we have another thing called like this mirror right here, you know, which is like a mirrored surface. See my hand? That actually makes sure things don't get too hot or too cold. Those are the types of things we put on the instrument to make sure that we can meet it thermally. And then we have other things like heaters. So we have some heaters here. That's one that's going to actually fly in space. But this is one right here that's just for our test. Here's one on our other test hardware. And so what we do is, you know, put a power supply through and make sure we can heat it up the way we want. So that's what we've been working on, and this is the actual instrument. Over here is again another part of the building, the spacecraft, and that's the inside of the spacecraft. And you see those big, you know, this really big black canister inside. There's actually 4 of them in there. And what those do, that's how it controls. That's called a gyro. It's kind of like a spinning top on the inside, and it makes sure that the spacecraft can stay straight when it's going around Earth with the instrument on top of it spinning. Also in here are the solar arrays, but they're kind of packaged up, so I can't show you. This flashing blue light means they're actually testing it right now. They're sending some signals through.